Hi grade 12s and welcome. In this video we're going to solve the Mathematics Paper 2 September 2023 preparatory examination, which is your trial examination for the province of KwaZulu-Natal. So let us go straight into question 1. Right, so we have question 1 here. Let's see. Mr. Sipokazi supplements his pension by mowing lawns for customers. He measures the areas in meters squared of 12 of his customers' lawns and the time y in minutes it takes him to mow these lawns. He works 8 hours a day, right? He recorded the data. So these are the x values, these are the y values. Question 1, determine the equation of the least squares regression line. So we're going to have y is equal to a plus bx. Now we're going to look at, remember, it's estimated line, so I'm going to put an upside down v representing estimation. Right, so let's punch this data into the calculator. You go to mode, stats mode, option number 3, and select option number 2. We're going to enter all the x values, which is 360, 120, 845, 602, 1190, 530, 245, 486, 350, 1005, 320, and 250. So I've got 12 data values, and let's enter the y values. We have 50, 28, 130, 75, 120, 95, 55, 70, 48, 110, 55, and 60. Right, so we've got 12 data set values. Press shift 1 because we want the equation of the least squares regression line, a plus bx. Go to regression, option number 5, and select number 1. When I select A, I'm getting an answer of 28,14. So we're going to write this answer down. 28,14 plus or minus. I think it will be plus. Let's see. Because the more area so the bigger the area, the more time in minutes it takes him to mow the lawn. So put your calculator on, shift 1, go to regression, option number 5, and press option number 2, and we can see that answer is positive, which is 0,09 x. Right, so we have our least squares regression line equation. 1.2, what's 1.2? Yeah, calculate the value of r. No need to calculate the value of r because the calculator will give us this answer, and you follow the same procedure, shift 1, right? You follow the same procedure, shift 1, put your calculator on, the data is still stored there, so shift 1, go to regression, option number 5, and r is your correlation coefficient, which is option number 3. So we are getting 0,91. Right, so r is equal to 0,91. Right, you can just write down the final answer. No need to use big formulas. Right, there is a manual method of working it out using the formula. It's there in the formula sheet. Question 1.3. Right, so how are we going to solve this? Given that Mr. Sipokazi charges a flat call-out fee of 150 rands, so that's basically his fixed cost. You have to pay this, as well as 50 rands per half an hour or part thereof. Right, estimate the charge for mowing a customer's lawn that has an area of 560 meters squared. 560 meters squared. Right, so you're going to put this value into x because x represents the area. So we're going to calculate the time in minutes it takes him. So 28,14 plus 0,09 times 560. So we're going to check how many minutes this is now. 28.14 plus 0.09 times 560. So we are getting 78,54. 78,54 minutes. 78,54 minutes is approximately how many hours? We need to divide by 60. So we are getting approximately 1,3 hours. Right, so for this 0,3 you still have to go and pay. You still have to go pay that 50 Rand per half an hour. So you got 3 half an hours here approximately. So in order to calculate the total cost, to find the total cost, we're going to say flat rate of 150 plus 50 times 3, because there is 1 full hour which is going to be 100 rands, so times 3, right? So you basically needs to do this, you need to round this up. You still have to pay for that 0.3 hours, so it has to be like 1,5. You have to round off to the nearest half an hour. That's a 1,5 divided by 3, and that's how you get 1.5. Shouldn't be divided by 3, should be divided by 0,5. Right, 1,5 divided by 0.5, 1.5 divided by 0.5, and that's how you get 3. Right, so 3 times 50 is 150 plus 150 is total cost is 300 rands. So that's the amount that you need to pay. Let's move on to the next question. Question 1.4. The local high school wants Mr. Sipokazi to mow their rugby field, which is rectangular, 100 meters by 70 meters wide. So remember, we're taking an area and we basically have a measurement here. So 70 by 100, right? We got 170. So that's going to be 100 times 70. Area is going to be 100 times 70 is 7,000. So that's your x value that you're going to enter, right? Because x represents the area. So remember our least squares regression line in 1.1, which is 28,14 plus 0,09 times 7,000. Right, so we need to solve that. 28.14 plus 0.09 times 7,000. So 658,14 minutes. Right, so it's going to take him about 658 minutes, which is approximately 658 minutes divided by 60 to get it in terms of hours. So which is approximately 10, which is approximately 11 hours. Right, let's move on to the next question. So the question is it possible for him to complete the job in one day? Now, how many hours a day does Mr. Sipokazi works? He works 8 hours a day. They told us this, right? So that's his day job. So 8 hours a day. So it's not possible. So is it possible for him to complete this job in a day? No, not possible, because the job will take him 11 hours to complete. 11 hours to complete. So it will not be completed in a day. Alright, it's open-ended, so you can write more. Not completed in a day, since Mr. Sipokazi works 8 hours a day, right? So you can say 11 hours is greater than 8 hours, therefore it is not possible to complete this job in one day. You can also write that down. Now moving on to question 2. Right, in question 2 we have a table with the frequencies and stuff, right? So let's see how we're going to solve this. Right, so the following table gives the frequency distribution of the daily traveling time in minutes from home to work for the employees of a certain company. Right, so what's given here is intervals, what's given here is frequencies, what's the midpoints of the intervals? Let's calculate the midpoints of the intervals. You take the lower and the upper and divide by 2. 0 plus 10 divided by 2 is 5. 10 plus 20 divided by 2 is 15. 20 plus 30 divided by 2 is 25, 35 and so on, and 45, right? Now to calculate the estimated mean, remember you need to take x times f, right? So this is x and multiplied by f. So if you take x times f, you're going to get all these values and divide it by the total. Right, so 20 times 5 is 100, 35 times 15, let's do this, and then I will show you how to use a calculator to solve this. Alright, 35 times 15 is 525. Next one, 25 times 30, 25 times 3 is 75, so 750 I will get here. 10 times 35 is 350, and 5 times 45, 5 times 45 I will get is 225. Right, so now I'm going to sum up all this. 100 plus 525 plus 750 plus 350 plus 225, and I get an answer of 1950. Right, and the total of the employees is how many we have here? We have 45, 45 and 35, so we got 100 employees, right? So what's the estimated mean? Estimated mean is equal to 1950 divided by 100, so you should get 19,5 minutes. Now what's the alternative way of calculating this? You just enter x and f into the calculator and get the answer, right? So let's enter that. Mode 3, which is stats, one variable. You can see when you have x, so press shift mode, scroll down, go to stats and put your frequency on. Now you can see x and frequency. So x was 5, 15, 25, 35 and 45, and the frequencies are 20, 35, 30, 10 and 5. Put your calculator on, press shift 1, go to stats, go to var, option number 4, and select option number 2. See, we got 19.5, so same answer. O is equal to 19,5. Now let me show you how to get this 1950 and 100. So if you go here, go to, put your calculator on, press shift 1, if you go to sum, which is 3, if you go to option number 2, that will give you the sum of all the values, 1950. And the total, if you want the total at the bottom, you put your calculator on, press shift 1, go to option number 4 and select option number 1. How many data values? N is 100. So 195 divided by 100 is 19,5. I hope you guys are understanding. Let's move on. Write down the modal class of the data. Right, very simple. Modal class is the interval that has the highest mode or the frequency. So what's the mode? 35. 35 is the highest number of employees. So the modal class is here, 10 to 20. So you just need to write that down. 10 to 20. That's your answer. That's it. Modal class. I hope you guys understood that. Moving on to the next question. Right, so they gave us the ogive curve. Right, so using the ogive curve, right, so the ogive curve is given for this frequency table. The ogive curve is already given. So construct a box and whisker plot for the data in the answer book. So how are we going to construct a box and whisker plot from this ogive curve? Well, we need some Q1, Q2 and Q3. So to find Q1, we're just going to go to 75% and get a estimated value from the ogive, right? So if I go, this is 80, alright? Remember the minimum is equal to 0. The maximum is 50. Right, now I'm finding Q1. Q1 is the 25 percentile, so that's 50. Where's 25 percentile? Is halfway between this 20, so 25 should be here. Right, so my Q1 is reading the values down. Now you can see these values are 10, 15, that's 5, 10, 15. So 12, 13, 14, 15. I think this should be 12, right? For 50, you're just going to read it off down, which is a median. You know how we're getting this? Because we took 100, the total, and we divided by 4. Right, so if you divide it by 4, you are going to get 25. So this is 25, read off the value on the x-axis. So I'm getting 12 there. Then when you divide by 4, you got 25. 25 times 2 is 50, or 100 divided by 2 is 50. So half of 100, or you can say half of 100 is 50. Read off the value on the x-axis. So this is about 15, 16, 17, 18. I think I will take 18. So Q2 I'll take 18. And 75 is somewhere around here. Right, so I'm reading off this value. Okay, so I'm going to take, let's see what I can take here. So I know I have 25 here, so I will take 26 or 27. Let me just take 27. Q3 is 27, right? Right, so now I've got my 5-number summary. Now I can construct the box and whisker plot. So I can take the same intervals like this, right? Yeah, let me just copy the intervals from here. 0, 10. Yeah, let's draw the intervals. Right, so I'm going to draw the box and whisker plot. So 0, got 5, 10, 15, 20, 25. This here should be given to you, right? Because you write in the special answer booklet, I think. Right, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I know the maximum is 50, the minimum is 0. My Q1 is 12, so 12 is somewhere around here. right? My Q2 is 18, right? Q2 is 18, and my Q3 is at 27. 27, somewhere around there. Right, so let me just box this up. Right, and remember there's vertical lines here. Right, so we're gonna write Q1, Q2, Q3. That's the maximum and that's the minimum. Now I already wrote all this down here, so the examiner can actually see what's the minimum and the maximum. I hope you guys are understanding, okay? If you have any question, don't forget to comment in the description box. Right, so far we have this, guys. I hope you guys are understanding. Moving on to the next problem. State whether the following statements are true or false, right? Now guys, from the previous question, if you look at it, right, remember I've estimated here, so you can like deviate by 1, right? You can either have an answer of 11, 12 or 13. You can have an answer of 19 or 17. You can have an answer of 26 or 26, yeah, 27, 26. You can deviate by 1 from the actual, answer. State whether the following statements are true or false. The distribution of these traveling times is positively skewed. Is it positively skewed? We need to look at the entire gap from Q2 to the maximum. Right, we can see there's a large gap here, so it is positively skewed. It is true. So this statement is true. The interquartile range for the data is 25. Is it 25? What's IQR? IQR is Q3 minus Q1. Q3 was 27 minus Q1, which is 12. Right? So I'm actually getting 15, not 25. So this is false. Right? 35 employees take less than 20 minutes. To solve this problem, 35 employees takes less than 20 minutes. What we need to do here is, let's look at the data given. 35 employees takes less than 20 minutes, but they don't, because between 10 and 20. So this should be false. We're going to say false, because we have 55 employees. Now how we get 55 employees is less than 20 minutes. Less than 20 minutes will be summing up everything less than 20. So it's between 0 and 20, less than 20. So 20 plus 35. So we're going to say 55 employees takes less than 20 minutes. Yeah, so this one should be false. Okay, I hope you guys understood that. Moving on to the next question, question number 3. BCD is drawn below with AD parallel to BC. The coordinates of the vertices are A, B, C and D. Everything is given on the diagram, right? BC intersects the x-axis at F. Right, so line BC intersects the x-axis at F. DCB is alpha, so we got an angle alpha here. AD intersects the y-axis at E. Right, so line AD. E is a y-intercept. Okay. Right, so the first question, calculate the gradient of AD. Let's take the first two questions and solve them. Right, so question 3.1, we want to find the gradient of this line AD. Right, so how are we going to calculate the gradient of AD? We got 2 points, right? So y2 minus y1 over x2 minus x1. So the gradient is 7 minus minus 3, so 7 plus 3 divided by 1 minus minus 4, 1 plus 4, which is 10 over 5, 2. You can use a calculator for that. Now gradient is 2, choose a point, determine the equation of BC. Now you want to find the equation of the other line, 3.2. Gradient of BC is equal to the gradient of AD, right, which is equal to 2 because BC is parallel to AD. That's my reason. Now you're going to say y minus y1 equals m into x minus x1 at the point C, because we want to find the equation of the line BC. We have the gradient, we need a point. Right, so that's your x value, that's your y value. So y minus y1, y1 is minus 8, so y plus 8, because minus minus 8, m is 2, x minus minus 2 is x plus 2. So we got 2x plus 4 minus 8. So y is equal to 2x plus 4 minus 8. Why minus 8? Because we brought that over. 2x plus 4, open this up. Right, so my equation is 2x minus 4. Right, so 2x minus 4 is the equation of the line BC. I hope you guys are understanding. Determine the coordinates of F. Right, so how are you going to find the coordinates of F? Yes, how are we going to find the coordinates of F? What is F? BC, line BC intersects the x-axis at F. Right, so F we can find, which is the x-intercept, make y 0. So from this equation, we're going to say 0 equals 2x minus 4. So 2x equals 4, x equals 2. You can see 2 times 2 minus 4 is 0. So x equals 2. So therefore the coordinates of F is 2, 0. Okay. Moving on to the next question. Right, so I need the diagram here to explain this. Right, so let's put the diagram here. Now what's happening is they're telling us that AMCD is a palm. AMCD, CD. So M needs to be somewhere around here. With M on BC. M needs to be on BC. So remember, I need to draw a line which is parallel to this. So I need a line which is parallel to DC, right? To show that this is a palm. Let me make this line, right? I'm just going to trace this line and we'll shift it parallel to show you where that point M is, right? So watch, this point M is right there. Okay, so point M is right there. So I have a point M here, So now this is a parallelogram. Now we're going to use a slide method to check. So in a parallelogram, whenever you're finding the fourth coordinate, you can just use a slide method. So from D to A, how are we sliding from D to A? So D was -4, -3 to A, which is 1 and 7. Now from -4, how you went to 1? You added 5 units to the right. And from -3, how you went to 7? You added 10 up. So we're going to do the same thing here. From C to B, we're going to add, from -2, we're going to add 5. So -2 plus 5. And from -8, we're going to add 10. So my coordinates of, we need to go from C to M, because M is the point on the parallelogram. AMCD is a palm. So M now becomes 3 and 2. So the coordinates of M is 3 and 2. I hope you guys are understanding. Okay, so I just use translation. I'm going to say by translation. Right, so that's how I solve this problem. Next problem. Show that alpha is 48,37. Now how do we show that alpha is 48,37? Show that alpha is 48,37. So we know it's usually big angle minus a small angle. So we know the gradient of this line BC, and it's an angle at the vertex here, right? So we need the gradient here, which is equal to 2, and we need the gradient of DC. So let's find, and we're going to say tan theta is equal to gradient, which is 2, right, for this one, because I'm finding that inclination angle theta there. Tan theta equals 2, so theta is now tan inverse 2, shift tan 2. That's going to give me 63,43 degrees, right? 63,43. Right, so I've got tan theta equals 2. Now I need to find the gradient of the other line, gradient of DC. I never find that. So the gradient of DC is equal to DC minus 8 plus 3, minus 8 minus minus 3, y2 minus y1, over minus 2 minus minus 4 plus 4. So I should get a negative gradient because it's downward sloping. So I've got minus 5 over 2. So minus 5 over 2. So now I say tan beta is equal to negative 5 over 2. So beta angle is now tan inverse 180 minus tan inverse, or you can say shift tan minus 5 over 2 and just add 180. So 180. So see what answer we're getting. Negative 68,20 plus add 180. If you're going to take out the negative, then you need to say 180 minus 68.20, reference angle, right? So beta angle is now, let me add 180. I'm getting 111.80, 111,80. So therefore alpha is big angle minus the small angle, 111,80 minus 63,43, and you should get an answer which is, yes guys, you should get an answer which is 48,37. let's check. Minus 63.43, 48,37. Right, so nice question. Right, and solving this next question. What's the next question after this? Calculate the area of triangle DCF. Area question. Now most of the time in analytical geometry, the area question is, let's see, calculate the area of triangle DCF. Triangle DCF. Right, now to calculate the area of triangle DCF, we can get the distance FC and the distance, yeah, we need the two distances. So let's get the distances right, and we can use the sine rule, area rule for sine. Obviously half AB sine C. You know what I'm talking about. Okay. Right, so let's see. To solve this problem, first we need to say that, look at DC. Right, so we're going to calculate side DC, right, and side FC. Now F is 20, so I need the distance DC. Use the distance formula. DC, right? So C is my final point, so I'm going to say minus 2 plus 4 squared. Remember x2 minus x1 squared plus y2 minus y1 squared minus 8 plus 3 squared. I'm going to leave the answer like that in third form, because it's always good to leave it in third form so your answers work out neatly, alright? And then to find FC, we're going to use the calculator for that just now. To find FC, that's my final point, so minus 2 all squared plus minus 8 minus 0, so just minus 8 all squared. Now let's see what this is. This is 64 plus 16, the square root of 80. Square root of 80 you should get, yeah, let's check what we're getting. Square root 80, I get, go and say square root of 80. Square root of 80, I'm getting 4 root 5. And over here I've got square root of 2 squared is 4 plus minus 5 squared, which is 25. Square root of 29. Right, so my area is equal to half root 29 4 root 5 sine of alpha. What was alpha? 48 comma sine alpha, it was 48 comma 37. Now let's enter all these values onto the calculator. So you got half times square root of 29 times square root of 80, remember what we had, times sine 48.37. So I'm getting an answer of approximately 18 units squared. Right, so I hope you guys understood that. Now moving on to the next question, question number 4. Right, so we have circle geometry here. First question, show that P lies on the circle. So the equation of the circle is given, right? Now because the equation of the circle is given, we want to show that P lies on the circle. So very simple to solve this. What we're going to do is we're going to take this point P and substitute it on the left hand side and see if it's equal. Left hand side is equal to 2 squared plus negative 9 squared. Why? Because x is 2, y is negative 9, minus 8 times 2 plus 6 times negative 9. Now if you work out all this, make sure you get 15, right? And 15 is equal to the right hand side. Therefore point P lies on the circumference of the circle, on the circle. Now we need to check this if point P actually lies on the circle. Let me just pop my calculator. Right, so I have my calculator opened. Now let's check if point P lies on the circle. Remember, we need to calculate this value. So we know this is 2 squared, which is 4. 9 squared is 81. Actually negative 9 squared, because we're squaring is 81. Minus 8 times 2 is 16. And we're going to minus 9 times 6, 54. Right, so we got 15. So we know that point lies on the circle. Moving on to the next question. Determine the equation of the tangent to the circle at the point P, which is 2 and negative 9. Now in order to solve that problem, we need center radius form, right? So we're going to look at the equation of the circle first, which is x squared plus y squared. I'm rewriting the equation of the circle in center radius form, CR form, right? Center radius form is x squared. Make sure to put the negative 8x, leave a space, plus something squared, right? Plus y squared minus plus 6y plus another something squared is equal to 15 plus, because we're adding something here and adding another something there, we need to add it on that side. Now what is this something? Minus 8 over 2, right? What is this? 6 over 2. So we put the same values on the other side, minus 8 over 2 and 6 over 2. Now automatically this first three terms here becomes a perfect square. We kind of like just completed the square there. So that's x minus 8 divided by 2 is minus 4, plus y 6 divided by 2 is 3, right, is equal to 15 plus let's work out all those values on that side. So we know we have 15 plus, remember this is minus 8 over 2 minus 4 all squared is 16, plus 6 divided by 2 is 3, 3 squared is 9. So we have 40, right? So if we try to imagine the circle, it has center which is 4 and negative 3. The center of the circle is 4 and negative 3. So that will be in the fourth quadrant, right? So center is 4 and negative 3. So remember the center is 4 and negative 3. If you try to imagine that, that's in the fourth quadrant, right? And the radius is root 40. We're not worried about the radius because we want to find the equation of the tangent to the circle. And point P is 2 and negative 9. Point P is 2 and negative 9, so it's going to be on this side, lower down. So point P is somewhere around here, right? 2 and negative 9. So we're trying to find the equation of this tangent, which is point P here, right? So just to visualize and try to make sense of the problem, right? Because it's 6 marks. So we know this point P is here. So to find the equation of this tangent, remember a radius is perpendicular to tangent, right? So first we're going to get the gradient of this line over here. Point P was 2 and negative 9. So we get the gradient of the radius, right? The gradient of the radius is yeah, that's the center. So in other words, the gradient of PC, we're going to take minus 9 plus 3, minus 9 minus minus 3, so plus 3 divided by 2 minus 4, right? 2 minus 4, I'm getting an answer which is negative 6 over negative 2, which is equal to 3. Now the gradient of the radius is 3, so the gradient of the tangent is equal to negative 1/3, because a radius is perpendicular to tangent, right? So remember, when radius and tangent meet, it is 90 degrees, and that's the reason radius perpendicular to tangent. Now we can substitute the point P inside here. So I'm using this formula y minus y1. What is y1? Negative 9, right? Is equal to m into x minus x1, x minus 2. Right, so now we're going to open this brackets up. So negative 1/3 x plus 2 over 3, and take this positive 9 on from the left hand side to the right hand side, we get negative 9. Now if you add up those two terms, remember, take negative 9 as negative 27 over 3. So you got negative 1/3 x. What is negative 27 plus 2? Negative 25 over 3. I hope you guys understood that. Moving on to the next question. Right, so it was important to draw the circle so you can make sense of the problem. Right, you don't have to put it in Cartesian plane. You don't have to put it on the x and y axis. Right, just try to visualize. You know the point 2 is to the left of point 4 and 9 is further down. Anyways, now we have a tangent drawn from Q, which is negative 10 and 12. Right, so negative 10 and 12 is going to be further way down here. So let me try to let's extend this line further. Right, so we have another tangent drawn from there drawn from negative 10 and 12 to the circle. Calculate the length of the tangent. Right, so nice question there. Right, so we're going to try and make sense of this problem as well. So just try to make sense of what they're talking about. There is they want, there's another, the tangent, a tangent is drawn from Q negative 10 to 12. Right, so this point here is negative 10 and 12. Right, now we want to go and calculate the length of the tangent. How are we going to calculate the length of the tangent? To calculate the length of the tangent, but we already have point P here. We already have point P here, right? A tangent is drawn from Q to the circle. Calculate the length of the tangent. Which tangent are they talking about here? They're talking about the length of tangent PQ. But that's so simple because you just need to apply the distance formula there. Or is it another tangent that are they talking about? Are they talking about this tangent here? Like drawing another tangent there? But they didn't say that's the second tangent. They just said that it was drawn from 10 and 12. Okay? I don't think they're looking at this tangent. No, let's take this out. It is that tangent that they're talking about. So how can we find this tangent length here? Tangent is drawn from negative 10 and 12 to the circle. Calculate the length of the tangent. The length of the tangent from where? From point P, from the point of contact or from the center of the circle? Right? So we have a problem here in this question. It's not clear. It's kind of like if you just calculate PQ, right, using the distance formula, the length of the tangent PQ, then let's see what answer we get. Let's use the distance formula. The distance formula is remember P to Q, so 12 minus 9, so 12 plus 9, sorry, let's do the x's first. Let's minus the x's. So what we got is minus 10 minus 2 plus 12 minus 9, so 12 plus 9. So the distance PQ I'm getting is, right, so that's quite big values. So this is basically minus 10 minus 2, so minus 12 squared, right, plus 12 plus 9 is, oh, you can enter the whole thing in the bracket, right? So 12 plus 9 and square that. I'm getting an answer of 3 root 65. 3 root 65. Right, so that's the length of the tangent PQ. 3 root 65. Is that correct? 3 root 65. Why is it 4 marks? Why is it 4 marks? What if you calculate? We can also use Pythagoras to solve this problem, right? Let's try to use Pythagoras. I think this is like another tangent that is drawn. Oh, remember, if it's the same tangent, then that's the answer. Or if you try to imagine this as another tangent, if it's a different tangent, if another tangent is drawn from Q, I think that's why I said this question is ambiguous, right? So if you're looking at Q as a different tangent, so you're going to say Q to C, the distance from Q to C is equal to, yeah guys, I think this is another tangent, right? Yeah, I don't think this is the same tangent. It's a different tangent that's drawn. Okay, so the distance from Q to C is, we're trying to get the hypotenuse, right? So Q to C is minus 10 minus 4 plus minus 10 minus 4, right? And 12 minus minus 3, so 12 plus 3, which is the square root of, I don't know what this answer is, let's check. So this is QC is square root of 14 squared, negative squared is positive, plus 15 squared. So I'm getting 421, right? And the radius is equal to square root of 40. Therefore tangent is equal to the square root of, I'm trying to use Pythagoras here, but not point P. We don't know what this point P is. If I imagine another, okay, so I'm imagining another tangent here, right? So tangent, the tangent is equal to QC, which is the hypotenuse. So I'm thinking of another tangent here, right? Remember, this is still the radius. Radius is square root of 40. So tangent will be the hypotenuse. Hypotenuse is 421. Square root of 421 squared minus square root of 40 squared, which is 40. So I'm getting square root of 421 minus 40. So this is the square root of 381, and the decimal value is 19,52. And what's the length of this tangent? 3 root 65. What is 3 root 65? I'm getting 24,19. 24,19. If it's the same tangent from question, if it's the same tangent from above, then that will be the answer. Else, if it's a different tangent, then this will be the answer. I think you should this question should be independent of the previous one, so I think you should take this, right? Yeah, I think I'm going to go with the second part because of the mark scheme. I don't think it's going to be so simple, straightforward problem in the last question. So let's take this out, right? So we're going to go with, provided we don't know, this is another point. So let's take this point out. Provided there's another point which is PQRS, let's call it S. Right, so tangent, we calculating tangent QS rather. Okay, so I hope you guys understood that. Yeah, this is more like tangent QS. And how did I get this? I forgot to write the reason. The reason is using Pythagoras. Yes guys, some questions you got to think, it can't be that straightforward, right? So this is from Pythagoras, right? So from Pythagoras, so that should be your answer. Okay, I'm going to go with the second one. Right, so moving on to the next problem, which is, let's see what we have here. Right, so now the circle is drawn in center radius form. So obviously you can get the center of the circle. Let's check how. The circle with center T, center is T, is given below with the equation. So the center T will be 3 and -2. So let's write that down. You know this is 3 and -2, right? So 3 and -2. Determine the coordinates of B. The radius, nice question, 3 and -2. So what we can do is from here to there, the distance from there to there is 3, right? I'm looking at the distance, no, not 3, that's 2. The distance from 0 to this point here, right, the horizontal, which is coming down 2 units, and the distance from there to there is 3. That's not important. Well, the radius is important. We know this is 5. The radius is 5, and O to K, you can call that K, that's 2. So the distance from O to B is Y. So you can say 2 plus Y. And the horizontal distance, we need the horizontal distance as well. The horizontal distance is 3. So problem solved. You can use Pythagoras. You can say Y plus 2 squared plus 3 squared is equal to 5 squared, right? We're using Pythagoras here, right? So we are using the Pythagoras. Now 5 squared minus 3 squared is 16, right? So we got y plus 2 all squared is equal to 16. So y plus 2 is equal to plus or minus 4. Now if you take the value of 2 over, you're going to get 4 minus 2, which is 2, or minus 4 minus 2, or y is equal to -6. So this is not applicable. So the coordinates of B will just be 0 and 2. I hope you guys understood that. Right, so nice question. So that's not applicable, yeah. Moving on to the next problem. Yes, how did we get BT to be 5 squared? How did we get BT to be 5? Is because we are given the equation of the circle. That's the center 3 and -2 with the radius square root of 25, which is 5. Remember the horizontal distance is 3 and the vertical distance from there to there. Okay, so I hope you understood that. That was in the previous question. Right, so next question, write down the coordinates of C. Right, so write down the coordinates of C if C is a reflection of B in the line x is equal to 3. Right, so we need to look at this problem again. Just 1 second. Let's take this diagram so I can explain this to you better. Right. We just need to write down the coordinates of C, okay? Now, it's a reflection. What was the coordinates of T? The coordinates of T was 3 and -2. Now it's a reflection about the line x is equal to 3. So x is equal to 3 is, there's it here, it's a vertical line which is parallel to the y-axis. So this is x is equal to 3. Now x is equal to 3 is here, and point B was 0 and 2, right? So the distance from here to there is 3, right? And the distance from there to there will also need to be equal to 3, right? Because it's a reflection about this line, it's reflected across, right? So you're reflecting, you're going 6 units to the right. So the coordinates of C will be 6 and 2. 6 and 2, because the coordinates of B is the same horizontal y. So therefore 6 and 2 is the coordinate of C. Right, so simple problem. Moving on to the next problem here. Another circle with center M, right, which is x minus 12 all squared plus y minus 10 all squared is equal to 100 is given. So the center is 12 and 10, and the radius is 10 as well. Calculate the distance TM. TM, that's simple because T is 3 and minus 2, and M is, so M is 12 and 10, right, and T is 3 and minus 2, right? So to calculate TM, therefore TM is equal to square root of, I'm applying the distance formula, yes, the square root of what? The square root of x2 minus x1, so 12 minus 3 plus 10 minus minus 2, so 10 plus 2 all squared, and we get an answer which is 12 minus 3 is 9, so 9 squared plus 12 squared. I'm getting square root of 225, square root of 225, I'm getting 15, right? So the distance between the centers is 15, right? So the distance between the centers of the circle, we're kind of looking at something like this, just to imagine, right? So looking at, there's T here, right, and M is like way up, right, because they said this is 10 and 12. So let me just explain this to you. And M is somewhere around there. There's another bigger circle here, right? So M is somewhere around here. We don't know whether they intersect or not. So let me make this look like a circle. Right, so we know TM, right? So we know the distance between the TM. I'm just drawing it like this for visualization. We don't know whether they intersect or not. Do these circles touch or intersect each other? So part B, we need to calculate R1 plus R2. R1 and R2. So radius 1 plus radius 2 is equal to, what's the radius of the first circle? The radius of the first circle is 5. How do we know that? There's it here. Remember we calculated the radius of the first circle is 5, right? Because of 25 there. And the radius of the second circle is not 15. The radius of the second circle is 10. Right, so 5 plus 10 is 15. Therefore, R1 plus R2 is equal to the distance between the centers. So what we can say, therefore, circles, do these circles touch or intersect? Circles touch externally, right? So they kind of do touch externally because they are equal. So let me just do this now. Yeah, how can we, yeah, so they basically touch each other. So this circle should actually be here, touching, not necessarily like this, because we know the distance between the centers, right, is equal to the distance between the distance of TM. So just to visualize this, is something like this, right? So the circles do touch. We didn't know that initially, that's why I just drew it separate. Right, so I hope you guys understood that problem. Now, moving on to the next question. Question 5, which is on trigonometry. So let's have a look at this question here. What do they want? See, the first question is, if sine 38 degrees is equal to P, then determine the value in terms of P without the use of a calculator, right? So we have to draw a triangle. So this is a basic question using triangles. Let me draw a triangle here. Now you don't need to draw this triangle in the first quadrant because there's no further conditions given. And you can see this is, yeah, you don't need to draw the triangle in quadrants. So we know 38 degrees is equal to P. So 38 degrees is at the bottom, P over 1, right? So opposite of hypotenuse, 1, P over 1, and the adjacent is the square root of 1 minus P squared. Don't write 1 squared because 1 squared is 1. Okay, and the top angle is 90 minus 38. So what's the top angle? 52 degrees. So always complete the triangle. Now, what is cos 218? Cos 218 is in the third quadrant because that's cos of 180 plus 38. And cos in the third quadrant is negative. So negative cos 38. And what is cos of 38 degrees? Adjacent of hypotenuse. So square root of 1 minus P squared with the negative outside. Right, so I hope you guys understood that. Moving on to the next problem. Cos of 14 degrees. Now obviously to get 14 degrees we need to use either compound angles or double angles or special angles. Right, so let's see if that is, if you can take a difference and get 14. Yes, we do get 14. 52 minus 38. So let's write that down. This is the same thing as saying cos of 52 minus 38. Now the expansion for cos is cos 52 from the formula sheet, cos 38. Do we take the same sign? No, opposite sign. Cos sine 52 sine 38. So nice question on compound angles, right? Now what is cos of 52? That's adjacent of the hypotenuse. Remember the hypotenuse is always here, it can't change. Only the opposite and adjacent changes according to the reference angle. So reference angle is 52. Cos 52 is adjacent of hypotenuse, so just P. Cos 38 is the square root of 1 minus P squared. Right? Sine 52, what is sine of 52? Opposite of hypotenuse. 1 minus P squared times sine 38. Sine 38 is P over 1. Right? So we basically have P into 1 minus P squared and P into 1 minus P squared. So final answer is 2P into 1 minus P squared. 2P into 1 minus P squared. I hope you guys understood that. Now moving on to the next problem. Let's move on to the next problem. Which is based on the same triangle. We got sine 26, cos 26. Now because you have sine 26 and cos 26, it looks like a double angle with the 2 missing, right? So 2 sine theta cos theta, so it looks like there's a 2 missing here. So if we multiply by 2 and then times half, so we can group up all this because we got 2 sine theta cos theta, which looks like a sine, right? So that's basically half sine 2 theta. Theta is 26 times 26. So I've got half sine 52. And sine of 52 using the triangle is opposite over hypotenuse, the square root of 1 minus p squared. So I've got half into the square root of 1 minus p squared. Right, so I hope you guys understood that. Now moving on to the next problem, which is evaluate the following trigonometric expression without using a calculator. So remember, to simplify this, we need to use maybe special angles, because I can see 45 and 15 and stuff. Special angles, double angles, and all your identities. Right, so we're looking at 2 sine 165, 195, so we're going to simplify this. So if we simplify this, we're getting 2. Sine of 165 is in the second quadrant, so that is sine 15. Cos 195 is in the third quadrant, so negative cos 15. How are we getting that? Because that's 180 plus 15 divided by, so you can see on the numerator we got 2 sine 15 cos 15, which is a sine double angle. In the denominator we got cos sine, cos sine, cos and sine, cos and sine. Okay, so we're starting with sine, we're ending with sine, and the middle is cos. So if you rearrange it, sine 15 cos 45, cos 15 sine 45. So sine cos, so it's a sine expansion. Sine of 15 degrees is my first angle, and my second angle is 45 degrees. Right, and on the numerator I've got negative 2. What is 2 sine 15 cos 15? I'm grouping all this up. Right, 2 sine 15 cos 15 is sine 2 times 15, which is 30 degrees. And in the denominator I've got something similar like that. I've got sine of negative 30. Right, so I've got sine of negative 30, which is negative angle. So negative sine 30 is half. Alright, so you can just write negative sine 30 over, denominator is also negative sine 30 degrees. So the answer is just 1. So evaluate the following trigonometric expressions without using a calculator. So I didn't use a calculator, simplified everything. 2 sine 15 cos 15 is sine 30, 15 minus 45 is negative 30, and sine of negative angle is negative sine angle. Right, so all good. So the answer is 1. Moving on to the next problem. Okay, so this looks like a difficult problem, right? So let's asterisk this. Given k is equal to root 3 cos x plus sine x, write k in the form t sine x plus theta. So that gives me a nice hint, because that can be sine x, start with sine. If you expand this, you're getting sine cos, cos sine. So let me start with k. K is equal to root 3 cos x plus sine x. What I'm going to do is, because I've got theta here, I think I'm going to just divide everything by 2 or multiply it by half. Let's just divide by 2 both sides. So what we're going to do is divide by 2 both sides. So that's going to become k over 2. That's root 3 over 2, and this thing is over 2, or you can say is times half. Now k over 2 remains as k over 2. Root 3 over 2, what is root 3 over 2? Root 3 over 2, you can write it as sine 60, right? Cos x plus, because we want it in terms of sine, and we're going to end with sine x, so this is going to be cos 60, which is half. Right, so now we're going to take the 2 across, because this part over here is a compound angle sine x plus 60 degrees, and we can take the 2 across, therefore this implies k equals 2 sine x plus 60. Right, so I hope you guys understood that. Moving on to the next problem. Right, quite simple, the next two problems, because they said must write down the value of t and theta. You can say t is 2 and theta is 60. We're just comparing here. There's t and there's theta. So t is equal to 2 and theta is equal to 60 degrees. Write down the maximum value of k. The maximum value of k is just 2. Max value is k is equal to 2. Just write down 2. Right? Which is the max value. What's the minimum value? Negative 2, because that's an amplitude. Alright, so I hope you guys understood that. Moving on to the next problem, which is prove the identity. Right, so we want to prove everything on the left hand side is equal to tan theta, because we already know the answer. Right, so we're going to say left hand side. That's a nice thing about identity. That's why it's simple, because you already have the answer. Right, so what's 2 tan theta? 2 sine theta over cos theta, because that's what tan theta is. Right, sine over cos. What is sine 2 theta? Sine 2 theta is 2 sine theta cos theta, right? And we're dividing it by 2 sine squared theta, right? Okay, you don't need to put brackets on top. We're dividing it by 2 sine squared theta, so I'm not going to do anything at the bottom. I'll just break up I'm going to write it as 2 sine theta sine theta, right? So I can take out 2 sine theta on the numerator as a common factor. So if I take out 2 sine theta as a common factor, I'm left with 1 over cos theta, right, minus cos theta, all over 2 sine theta cos theta. Now we know the 2 sine theta and the 2 sine theta cancels out. So far so good. Now you can see you got 1 over cos theta. Let's simplify the denominator. Let's simplify the fraction here. Make it over 1. Right? And we got 1 over cos theta. So your LCD is just cos theta. Right? For the numerator. And we're dividing it by cos theta here. So dividing by cos theta is the same thing as saying multiplying by 1 over cos theta. Right? So what we have on the numerator is 1 times 1, which is 1 minus cos squared theta. Now 1 minus cos squared theta is sine squared theta, and cos theta is cos squared theta. And what is sine squared over cos squared? It is tan squared theta, which is equal to right hand side. So it's proved. Right, so we all good. Remember 1 minus cos squared is a sine squared theta. Next question. Hence, determine the value of theta, where theta is between 180 and 360, which will make the above identity undefined. When will the identity be undefined? The identity above will be undefined if the denominators are 0. If 2 sine squared theta is equal to 0, don't forget the zeros of tan theta as well. Tan theta is sine theta over cos theta. So either 2 sine square theta is equal to 0 or tan theta is equal to 0. The answer should be tan square theta here, right? Not Yeah, let's check if this is right. 2 sine theta over cos theta minus 2 sine theta cos theta. 2 sine theta came out from there. 1 over cos theta minus cos theta. 1 minus cos square theta times 1 over cos theta. Yeah, it should be tan square theta. They made a mistake here. It shouldn't be tan theta here, right? Or not tan theta equals 0. Or when tan theta is undefined, tan is sine over cos, or cos theta is equal to 0. Right, so 2 sine square theta equals 0. If you divide both sides by 0 and take a square root, you're still going to get sine theta when sine theta is equal to 0, or when cos theta is equal to 0, taking square roots on both sides. Because square root of 0, you don't have to say, if is plus minus 0 is still 0. So when is sine theta equals 0 between 180 and 360, you can think about the sine and cos graph. So sine is 0 at 180 and 360, right? So theta equals 180 degrees, 360 degrees, and don't forget about cos theta. When is cos 0? Cos is 0 at 270 and 90, but we don't want 90, or 270 degrees. So these are the values of theta when this identity will become undefined, right? So I hope you guys understand this. Just want to go back and check if this is true. 2 tan theta minus sine 2 theta. So 2 sine over cos minus 2 sine theta cos theta. Right. Yeah, guys, this here should be tan squared, not actually tan theta. Otherwise, if it was tan theta, we wouldn't be able to solve this identity. Is it possible to be tan theta? It's not possible. Let's see. Sine over cos minus 2 sine theta cos theta. I did that correctly. This sine theta is just sine theta sine theta. 2 sine theta cancels out. 1 minus cos squared. And cos times cos is basically cos squared, sine squared over. Yeah, that's the identity. Right, moving on to the next problem. I don't know why they have errors in this paper. Right, so if you think there's no error, don't forget to comment in the comment section. Right, thank you. Let's move on to the next question. Question number 6. Which is on trig graphs. Sketch the graphs of f of x and g of x. F of x and g of x. We have f of x, which is 2 sine x, and g of x, which is cos x minus 30 degrees, for x is an element from minus 180 to 180. I think I'm going to go with the 30-degree intervals, alright? Indicate the intercepts with the axes and also the turning points. So I'm going to draw it because I don't have an answer sheet here. Right, so I need to go 2 up. So I will use these intervals as 2 and 4, half and 2. So that's half, that's 2. No, it should be 1 and 2. Alright, so this is 1, that's 2. This is minus 1, and this is minus 2. Right, so this is the x-axis and the y-axis. Now on the x-axis we want 6 intervals, because I'm using 30-degree intervals, right? 30, 60, 90, 120, 150, and 180. Make sure it's kind of like spaced out. Right, so that's 90 here, right? 0, 1, 2, 3. That's 90 there. It's a bit too far. And try to get a smooth curve, right? And that's 180 there. Now let's put these functions onto the calculator. 2 sine x, that's quite simple because sine graph starts from 0, right? And sine of 90 is 1, but now in this case it's going to be 2 because times 2. And then you know sine 30 is half, and half times 2 will give me 1, so it needs to go through that. So let's try to get it as symmetrical as possible. So this graph is going up and then coming down to 180, alright? And then similarly it's going to go down. Negative 30 is, right, it's going to go there, there. We need it spaced out there. Sine 30 is half, and half times 2, right? And let's see, of 90, 120, 150, sine 150 will be at the next spaced out point. So there. And we're going to join all these points for the sine graph, right? I'm just going to draw it in my highlight. Is a little bit more smoother than the actual pen. So I kind of went off from here. So I'm just trying to draw the sine graph, alright? Guys, you can also use the calculator, right? Right, so I've got a nice sine curve, which is f of x. Let's label this graph as f, right? That's the graph f. And now the graph of g is basically the cos graph, which is shifted 30 degrees to the right. So if you go to mode, table 7, you just enter f of x, 2 sine alpha x, close the bracket. G of x is cos alpha x minus 30 degrees, right? Starting at negative 180, ending at 180, and stepping 30 degrees, right? So these are all my values. As negative 180, I've got 0 and negative 0, 866. So where can I put negative 0, 866? Where can I put negative 0, 866? Let's put a line here for negative 0, 866. Negative 180 for the cos graph. Right, so I'm more interested in the zeros of the cos, right? So at negative 150 I get negative 1. At next value of the cos, negative 0, 866. But why is it turning like this? Negative 0, 866. Whoa, negative 1 is here. Sorry. That's why I'm thinking what's happening here. Alright, so negative 1 is right here. Right, so far I have a curve that goes like this. At 90 you should get 0. 90 you're getting negative 0.5. Okay. At negative 60. At negative 60 I'm getting this point here. At this point, at negative 30 I should get 0.5. Let's check. Negative 90 I've got 0. Negative 60 I've got 0, right? Negative 30 I got 0.5. And then at 0 I got 0.866. At 30 degrees I'm going to get 1, right? And then this will be 0.866. Then at 90 I will get 0.5. Let's check. 1, 0.866. 90 I got 0.5. Then at 120 I got 0, right? Then at 150 I got negative 0.5, and then at 180 I've got negative 0,866, so somewhere close here. Right, so I'm going to draw this graph. Let's draw it in a different shade here. Let's draw it in a green color. Alright, we've got some nice points of intersection here, because when we're trying to do f of x and g of x and stuff, right, that's going to be quite simple to solve. Just this point is a bit off. Right, so this is my g graph. Right, so we have our f and g graph. Indicate the intercepts with the axis and also the turning points. There's all the turning points here, right? So the turning point is at -2, at -90 and -2. This turning point is at -150 and -1. Intercepts, this intercept here is 120 degrees. Did we indicate all the intercepts? Yes, we did. This point here is 30 degrees and 1. This point over here is 90 degrees and 2. Right, so we've got all indication here. We have indicated everything. Next problem, write down the period of, so we're just solving these basic problems, right? So you can just do it in like one step. The period of g of x, where's the g of x graph? G of x, the period is just 360, because we got half a wave. Yeah, the period is basic, the period is 360. There we have half a wave from there to there. Here another half here. Half a wave takes 180 degrees, so full wave will take 360. So write down the period of g. The answer is 360. Determine the values of x for which f of x is greater than g of x. When is f of x greater than g of x? When is the f graph above the g graph? At -180, but we have to include -180 because it's always above. At -180, remember, where's the f graph above the g graph? F is the yellow graph, so -180 including to -150 excluding. So -180, x is an element from -180 to 150 excluding, or union, or from, we want f above g, right? F above g, there's it here, from 30 degrees to 180 including. And from 30 degrees to 180 including. Or you can write it like this: x is greater than or equal to 180 but less than 150, or x is greater than 30 but less than or equal to 180 degrees. So I hope you guys understood that. Now the last question in this is 6.2.3. Right, let's see how we're going to get this. Write down the values of x for which f of x is equal to 1.5 plus g of x. Now you can also write it like this: f of x minus g of x is equal to 1,5. Where is the difference between the f and g graph? 1,5. In other words, f graph needs to be above minus below. The difference between the two graphs is 1,5. When? So let me just copy this, right, and explain it here. So when is the difference between the two graphs equal to 1 comma 5? So where is it? 1 comma 5. I can see a point here between F and G. So there's a point on F. I can see the difference between the two graphs is here. Right, so I've got an answer for X which is equal to 120, 150 degrees. There should be other points. Is there any other point here? Yes, I found another answer here. No, but this was 0.866. We want 1.5. At 90. Oh, okay, this point was a bit messed up. At 90, I think it was here. Cos of 60 was half. That point is half actually. Alright, so that point is half. So I think, yeah, there's another point here is at 90. Right, so you can check that up because cos of, if you substitute 90 minus 60, it is half. Cos of 60 is half, and that's 90. 2 minus half is 90 degrees. Right, so we got two answers. It's either 90 or 150. 90 or 150, that's it. Because the F graph has to be above and this is below. And I don't think there's any other points. Nope, there's no other points. Alright, so at 90 and 150. I hope you guys understood that. Moving on to the next question, question number 7. Let's see what is question 7 about. Right, this is on solution of triangles 3D problems. Right. So in the diagram below, PQ is a vertical tower, vertical mast. R and S are 2 points on the same horizontal plane. These are the horizontal planes, right? QRS is alpha 8 minus 2x. Is that information given? Yeah. SQ is equal to x. Right, so most of the information is given. The angle of elevation of P, the top of the mast from R, is theta. So that's already given as well. Now express PQ and QR in terms of QR and trigonometric ratio of theta. So what is PQ and QR? PQ, QR, you're going to get tan. Tan theta equals PQ over QR. Let's write that down. Now if you cross multiply, you get PQ is equal to QR tan theta. Okay, that looks like theta should be QR tan theta. I hope you guys understood that. Moving on to the next problem. Show that PQ is equal to. Right, very basic problem, guys. Right, so we want to show that PQ is equal to, let me just put this on top. Right, so 7.2, we want to show that PQ is equal to this. See what they're using? PQ. The distance PQ is equal to, remember what was PQ? QR tan theta. So find QR. How are we going to find QR? We got, how are we going to find QR? I think we can use the sine rule, right? So we can say QR, we got x here, we got x there, we got angle, side. So we can say sine beta over QR. You can say QR over sine beta is equal to QR over sine beta is equal to x over sine alpha. Right, so I'm using the sine rule. That over that, the side over the angle. Now, what is QR? QR is already PQ. What is QR? Yeah, what is QR? That should be tan theta over PQ. we want to say what is PQ. PQ. So what is QR from here? From here, what is QR? QR is PQ over tan theta. So let's write that down. PQ over tan theta. That's QR. Oh, just take sine beta across. So QR is equal to x sine beta over sine alpha. But we know QR is PQ over tan theta. Right. So what we can do is take tan theta across, cross multiply, x sine beta tan theta over sine alpha. Next question. What's the next question? The next question is, if B equals 60 degrees, calculate the area. Right, so quite simple as well. If beta is equal to 60 degrees, now they're telling us beta is 60, show that the area of triangle QSR. So beta is 60, so QSR is going to be x, and multiplying the x with the 8 minus 2x and half, so a half x 8 minus 2x sine 60. So half x into half x into 8 minus 2x sine 60 degrees. Remember, for sine rule we have something like this. We got this side given, that side given, and we got the angle given. So multiply the two sides, sine of the angle, and multiply by half. So half times the sum of the product, half times the product of the two sides, sine of the angle. So we got half into, let me just leave this as, okay, let's open this up. We got 8x. No, we're going to open the whole thing up. Half, actually don't open the whole thing up. We got sine 60, so let's write, no, let's open it up. So we got half times 8, which is 4. We got 4x, right? Half times 8 is 4, 4 times x is 4x, because we're distributing this entire half x inside. Now half times 2 is, what's half times 2? 1. And x times x is x squared. So we got minus x squared. And sine 60 is root 3 over 2. Okay? Now root 3 over 2 times 4. So it's kind of like saying half of 4 is 2. And 2 times 3 is 2 root 3 x. And minus root 3 over 2 x squared. We're distributing this in the two terms. So I hope you guys understood that. Moving on to the next problem, which is 7.4. Determine the value of x for which area of QSR will be a maximum. Now, how do you maximize this? To maximize this, you can use minus b over 2a, or find the derivative. So you're going to say dA dx. If you take the derivative of this, is 1 times 2 root 3, so you just get 2 root 3, minus 2 times root 3 over 2 is just root 3, x, taking away 1 from the power, is equal to 0. We can divide everything by root 3. So root 3 cancels out. So you just have 2 minus x is equal to 0. Therefore, x is equal to 2. Determine the value of x for which area of triangle QSR will be a maximum when x is equal to 2. Right, so I hope you guys understood this entire problem. Right, so quite basic, simple. Now moving on to the next problem, question number 8. We want to prove that angle as center is equal to twice the angle as circumference. So if you look, if you read the story in the diagram, O is the center of the circle and M is a point on the circumference of the circle. Arc AB subtends angle AOB, at the center of the circle M and at the circumference of the circle, right? At the center of the circle O, arc AOB subtends, where is it? Arc AB. Arc AB, this is the arc, it subtends an angle at the center and then angular circumference. Use a diagram to prove the theorem that states that AOB is equal to 2 times angle M. Simple. First thing what we do is we construct this line passing through the center. So say construct line MO, right? MOD. MOD, right? So let's write here, construct line MOD, right? Make sure the construction line is basically in broken lines. Then we say let angle M1 be equal to angle M2 be equal to X. Now why let angle M1 be equal to X and angle M2 be equal to Y. M1 is X, M2 is Y. X and angle M2 is Y. Now we want to prove that O1 plus O2 is 2 into X plus Y. In other words, 2X plus 2Y. Now let's check. So the proof, right, starts here. We can say, remember, MO equals AO equals BO radii. Right? So AO equals BO equals MO, thus radii. Right, so we're going to mark all this equal, right, because they are radii. Now remember I said angle M1 is X. So if angle M1 is X, what's angle A? So we're going to write angle M1 is equal to angle A is equal to X because we have an isosceles triangle. We're going to say angles opposite equal sides. Please don't write isosceles triangle. It's angles opposite equal sides. Same here. Angle M2 is Y, angle B is Y. So angle M2 is equal to angle B is equal to Y. Same, angles opposite equal sides. Right, so we have that. Now, what is angle O1? If you remember, exterior angle of a triangle. Remember angle O1, we're looking at angle OAM, actually MAO. So that's an exterior angle of a triangle. Or if you try to find this angle here, that's 180 minus 2x, then you're going to get this to be 2x. So angle O1 is equal to 2x. That's exterior angles of triangle MAO. And similarly, angle O2 is equal to 2y because it's an exterior angle of triangle MBO. Exterior angles of triangle MBO. Now, what is this entire angle AOB? So we got 2x here and we got 2y here. So AOB is equal to 2x plus 2y, which is summing up angles, so no reason. So we got 2 into x plus y. Now what is x plus y? M1 plus M2. So which is equal to 2 times angle M, and that completes the proof. I hope you guys understood that. So AOB is equal to 2 times angle M. Moving on to the next question. Question number 8.2. Right, so I'll do the first 2 questions there, then we'll crop the next one below it. So make sure when you read the question, you also mark off the diagram, right? So let's see. So from a point A outside the circle, center O, we have center O, so we know that these are radii. 2 tangents AD and AV. Now remember, when we have 2 tangents from external point, so they are equal as well, right? So this here basically becomes a kite. So we can say angle M1 is 90. Okay. AD and AV are drawn. AO and VD intersect at M. BOD is a diameter. BOD is a diameter. So we know this entire angle V1 and V2 is 90 because the angle's in a semicircle. This is diagonals of kite. That's the reason why that is 90. Now, if that becomes 90, then you know, line from center perpendicular to chord, that becomes, let me mark it with a different marking now. Can't use the same marking. So, right? Okay, so those are also equal, line from center perpendicular to chord. And either way, diagonals of kite, you know, the longer diagonal cuts the shorter diagonal in half. So anyways, you can use so many reasons here. BV and VO are drawn. VAD is equal to 40 degrees. Where's the 40? See that 40 degrees is not represented here on the diagram. VAD, this entire angle is 40 degrees. But now we already know that this is a kite, so it has to be 20-20 because the longer diagonal bisects the angles, the vertex angles. See, the longer diagonal will bisect the vertex angle. So that's 20-20. Oh, so this is quite simple. Remember, there is also a radius perpendicular to tangent. So remember, this is also 90 there, and that's also 90 over here. But now since this is equal, that's kind of like congruent. So either way, we can use so many reasons. Prove that quad VODA is cyclic. Right, so we can see that this is a cyclic quad because this angle D and angle V over here, they are 90-90, and opposite angles of cyclic quad are supplementary. So VODA is cyclic. VODA is cyclic. Yes, it is a cyclic quad. This right there. OVA. So 8.2.1 OVA is equal to 90 degrees. OVA is equal to 90 degrees. Reason, a radius perpendicular to tangent. And then ODA, guys, you don't have to use 3-point notation. You can also break it up here, V2 plus V3. But over here, you don't have an option. Just write ODA is equal to 90 degrees because that's a radius perpendicular to tangent. Right, so we know that these are two tangents. So this implies OVA plus ODA is equal to 90 degrees. Therefore, VODA is a cyclic quad. Right? And what's the reason? Converse, opposite angles of cyclic quad. Converse opposite angles of cyclic quad. Or you can write, why did I write 90? It's supposed to be 180. 90 plus 90 is 180. You're going to write opposite angles of quad are supplementary, therefore VODA is a cyclic quad. Right, so I hope you guys are understanding. Converse opposite angles of cyclic quad, supplementary. Make sure you write supplementary as well. Right, next one, calculate the magnitude of angle O1. Angle O1. Angle O1 here. What is the size of angle O1? So we know angle O1 has to be angle at center is equal to twice angle at circumference. So if we can find this angle D here, the size of angle O1. Okay, since this is cyclic quad, that's easy because now opposite angles of cyclic quad, O2, O3. Remember, this is a cyclic quad already. So remember that this is a cyclic quad. Oh, if this is a cyclic quad, right? I just mind the drawing, right? So this is a cyclic quad. Then opposite angles of cyclic quad or you can just say exterior angles of cyclic quad. Look at angle O1. Angle O1 is an exterior angle of cyclic quad. So angle O1 is also 40. We can write angle O1 is equal to angle A is equal to 40 degrees, because exterior angles of cyclic quad, what's the cyclic quad? VODA. Okay, so far we are good. Next question. Yeah, the next question was basically, 5 marks. So that's the reason why I just left that out. And now let's do it here. I need a diagram for the explanation here as well. So let's put our diagram. Right, so remember, we need to prove parallel lines. So we need to work with fun angles, either co-interior, corresponding, right? Corresponding, co-interior, and alternate. So we want to prove that BV is parallel to OA. BV is parallel to OA. Right, so is it parallel? So we can get 90, 90, okay? So we got angle V1, V2 to be 90, all right? And maybe we can get angle M3 to be 90 as well. Right, but remember how we said angle M3 is 90? We said it was basically diagonals of kite. I don't know why I don't know whether if we can use diagonals of kite, but we can clearly see that this is a kite, because we have AV equals to AD. We have angle, we can prove that to be alternate. We got 40 degrees there. Right, so remember we have 40 degrees here. Yeah, let's work with these to get this to be alternate. So we have 40 degrees here. Right, so now we know that this is an isosceles triangle. So if this is 40, 180 minus 40 is going to give me 140, and then divided by 2. So we will get 70 here and 70 there. Then angle D will be, what will angle D be? Remember, sum of angles of triangle. Sum of angles of triangle, we can say this is 70, that's 90, so angle D will be 20. Okay, so we don't need to do that. If this is 20, we can just say angle of center equals twice angle of circumference, so that's 20. Then we know that these are also isosceles, so that's also 20. Well, if you have 70 there, we got 20 here. We don't really need to find the 70, so we're going to use the 20 here and the 20 there. And we're going to get sum of angles of triangle here. Opposite angles of cyclic quad, that's fine, that's 20. This is 90 here. If this is 20, then this is 70, because of this here being 90. Alright, and if this is 70, should we prove congruency here? I'm sure we can use diagonals of kite, because diagonals of kite intersect at 90 degrees. Yeah, I think I'm going to use diagonals of kite. We're going to say AV equals VA, AV equals DV, AV is equal to AD, AV is equal to AD, AV is equal to AD, because it is AV is equal to AD. The reason for that, AV is equal to AD, because tangents from common point, tangents from, we had all this before, right? Common point. We got AV equals AD, tangents from common point. We know that angle BVD is 90. I'm trying to get this one to be 90 and that one to be 90. All right. So tangents from common point. So we can say AV VODA is a kite. VODA is a kite. Why it is a kite? Because we have adjacent sides equal. Right, so since this is a kite, we know that BVD is 90. BVD is equal to 90 degrees because we have angles in a semicircle. Right? BVD is 90, and now we got we got diagonal OA and VD perpendicular. So we know BMA is equal to 90 degrees. We're going to write diagonals of kite because we proved that it's a kite already. Diagonals of kite intersect at 90 degrees, and now we got BVD is equal to VMA or AMV. Right, because we got or you can say anything here now. You can even say angle M2 is 90. So what we have is now corresponding angles equal. So we got corresponding angles equal. This implies that BV is now parallel to OA. BV is parallel to OA. Is that what we wanted? Yes, we did. Right, so any other methods that, any other approved methods, obviously your geometrical reasoning, you can also solve that. So we can also solve using geometrical reasoning here. Right, so maybe look at this. We got 20 degrees here. We got 70 there. We are doing the right thing. We got 70 here. We got 20 here. Maybe if you can prove that angle O2 is 70. But how? Because we need how can we get angle O2 or O1, O2 or O3 to be 70? There's it here. Angle as center. Can you get angle as center here? Angle O2, and if you can get angle O2 to be 70 degrees, then we have an alternate angles here. How can you get angle O2 to be 70 degrees? You can try that out. This is 20, this is 20, this entire thing is 140, and I'm just stuck over here to get this angle O2 to be 70. So maybe like this. Angle as center. No, we don't have angle as center there. Do we have tan chord theorem? Can we do tan chord tangents and chord? No, that's tan chord there. Going tan chord from this side, and you go to angle 20 here. That's also 20. Yeah, we're just trying to get angle O2 to be 70 degrees. Tan chord from this side. Okay. So because these are equal chords, so you need to write that down. Because this is 70, then we can get tan chord from here. No, but this is not tan chord from here. Directly opposite the chord. No, that's not tan chord there. This is 70. 70 here. We got 70 degrees here. It's just not helping us to get to 70 over here. Directly opposite. It's going to be 70 there. 20 there. Yes guys, this entire angle is 140. If I can get angle as center, no, I can't get angular center there. Just okay. So this entire angle here is 40 degrees. I'm just trying to get angle O2 to be 70. How? That is 70. Too many angles here. 70, 70. Can this be an exterior angle? No. We can say angle O2 is equal to angle O3 if we prove congruency. Right, so if we choose OAD and OAV, we can say this is 90 and this is 90. 90 degrees, OA is common. 90 degrees hypotenuse, and there's a side here. So 90 degrees hypotenuse and a side, then you can say angle O2 is equal to angle O3. I think you have to go the congruency route. Oh, okay. There is another way. Remember we proved that this is a cyclic quad. Because this is a cyclic quad, we can get angle O2 to be 70 because angle subtended by equal chords. See, AV, that's angle subtended there on the circumference, and AD also subtends an angle there. So this is, both of them are 70 and 70 because this entire angle was, yeah, so you can use that reasoning as well. Right, so there's so many ways to do it. I just found that this is a kite, that's 90, and then there. I hope you guys understood that. Moving on to the next problem. Question 9. Let's do question 9. Looks simple though, just 2 marks each. A line drawn parallel to one side of a triangle, yeah, divides, basically this is a proportionality theorem, divides the other two sides, proportionally. Right. A line drawn parallel to one side of a triangle divides the other two sides proportionally. Divides the other two sides in proportion. Okay, in proportion. Right, so we good. Let's calculate these. Now make sure to find a triangle that has a parallel line inside. There's so many parallel lines, 3 different parallel lines, crazy. In the figure, KL is parallel to QR. Okay, we got all that. We just need the important points. We got 3 different parallel lines. PK is 3 units. PK is 3 units. They're giving us the actual values, not in ratios. PL is 4. LR is 6. Right? And MN is 1,8. Right, so if obviously if LR is 6, we can get KQ. Calculate the length of KQ, right? So 9.2.1. So KQ, I'm going to say KQ over PK. KQ over PK, because I'm looking at this triangle PQR. KQ over PK equals LR over PL, right? And this, the reason for this, what's the reason for this? We're going to write prop theorem. Thus prop theorem. Why it is prop theorem? Because KL is parallel to QR. Right, so I hope you guys are understanding. Now, what is KQ? That's what we need to find. So KQ is now equal to, remember we're going to take the PK across. What is PK? PK is 3 times, what's LR? 6 over 4. Right, so we're getting an answer for KQ. 3 times 6 over 4, we get an answer which is 9 over 2. So we're just going to write 4,5, right? So this is 4,5. Perfect. Moving on to the next problem. Prove that QM equals NR. How is QM equals to NR? That should be X and that should be X. QM is equal to NR. Okay, so first thing what we can see here is that we kind of have like a parallelogram here, isn't? NR and KL, they will be equal, X and X. That is 6 and this will also be 6, opposite sides of palm, right? And then we have a parallelogram here. So what we're going to write is KLRN is a palm, right? So that is why, because both pairs, no, why we need to write this? We can already see that is a palm, right? So let's take this out. 9.2.2. So what we're going to say is KL is equal to NR. We're going to write opposite sides of palm. Which palm are we looking at? KLRN. 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 Okay. And then remember we made that equal to X, so it's fine. You can make it equal to X. And then we got KL is also equal to QM. KL is also equal to QM. And that's also equal to X because opposite sides of palm. Which palm are you looking at now? KLMQ. KLMQ. So this implies that QM equals NR. Right, so I hope you guys understood that. Very nice problem. Testing on properties of quadrilaterals. Even the previous one, I used a kite. Over here, we're using parallelograms. Amazing. Let's move on to the next problem. Okay, we got 2 more problems after this. Alright, so let's look at question 10. Alright, so we have question 10, which is based on similarity. So as you can see in question 10.1, so we want to prove that 2 triangles are similar. So in question 10 we have in the figure 2 circles intersect at A and B. Right, so 2 circles intersect at A and B. Alright, that's it. AB produced to M bisects QAR. Very important to read, guys. QAR. QAR. The line AB bisects QAR. So I'm going to write down, let's just put the dot there. Right, so both of them are X and X. Tangents MQ and MR. Tangents MQ and MR. Remember, they don't touch the same circle, so you can't say they are equal, right? Meet at the circle Q and R respectively. They are different circles. QBR is a straight line. QBR is a straight line, okay? AQ and AR are drawn. AQ and AR are drawn. Now because we have tangents, remember we can do tan chord here. Angle Q1 is equal to angle A1, right? And angle R1 is also X. Now we can say that they are equal because we got base angles to be equal, right? And what else can we conclude from here? What else can we conclude? Remember, the angle on this side will be equal to angle B2 here, tan chord, right? And the angle on this side over here, angle NRA, will be equal to angle B3 over here, right? So just keep that in mind. Now we want to prove that triangle MQA, MQA, so this entire triangle here, 1, right? So MQA is similar to triangle MBQ, MBQ, MBQ. So we got angle M to be common, right? So this is a second triangle. So the first triangle is this entire thing here. So we got Q1 be equal to angle A1. We got angle M1 is common, and then remaining angles, which is angle B1 is equal to angle B1 would be equal to the entire angle there. Yeah. So let's write in triangle MQA and triangle MBQ, MQA and MBQ, we have 1, 2, 3. We got 3 things. So the first one we have is angle Q1 is equal to angle A1, right? That is tan chord theorem. The second one is angle M1 is common. So I used up angle M1 and angle Q1, and then angle B, angle B1 is equal to, so I used angle A1 here, there, is equal to angle MQA. That's remaining angles, or third angle of triangle, or you can say, I like to say sum of interior angles of triangles, right? Or third angle of triangle, right? So what we have now is therefore triangle MQA is now similar to triangle MBQ, right? And the reason is angle, angle, angle. Next one. Oh yeah, next one was using this information to prove that MR squared. That's basically 5 marks. So we got to think a little bit here now. I don't think it'll be that simple. We want MR squared. MR squared. So we have MR here. Must be, so we dealing with this side here, which is MR. But now remember, MR will now be equal to QM. So you can also take QM from here. MR and QM. So we're basically dealing with the MR. We clearly don't have MR here, but we got MQ, right? Is equal to AM times MB. AM times MB. Okay, I have the, so what we know is that angle A1 is equal to angle A2. Angle A1 is equal to angle A2 is equal to X. Angles bisected, right? Bisected by line. Angle was bisected. angle A1 equals angle A2, which is x. We got angle Q1 is equal to angle A1. We did that already. We can say angle R1 is equal to angle A2. We know angle R1 is equal to angle A2, which is also equal to x, because that is tan chord theorem. Now we've got x, so now what we can say is qm equals mr. So very important analysis here. Qm equals mr. Why is qm equal to mr? Qm is equal to mr because we have sides opposite equal angles, right? Now remember, we also proved that, let's just write the other one as well. Let's not leave out any information. So what we can say here is that, remember, angle Q1 is equal to angle A1. So I'm basically just copying this, right? So just write it here as well, even though it's not necessary. We proved it above, right? And that's also equal to x, right? And that's tan chord theorem. Let me just separate this, put the reasons in the side. Right, so now we got qm equals mr. Qm equals mr. Now we can use this. Now you can see you got qm. You can say qm over mb, alright? Because we need mb and we need am. So am over mq, right? So that's what we can say now. So we're going to say qm over qm over mb, qm over mb equals am am over mq. Now the reason for this is because from similar triangles, right, we prove similar triangles from above here. Now what we can say is we have mq squared, qm squared, see, qm squared cross multiplying, qm squared is equal to am times mb. But now qm is equal to mr. Problem solved. Because qm is equal to mr, right? We just proved that now. Right, so perfect, simple, wasn't so bad. Moving on to the next one. We got mq squared over mr squared is equal to 1. Mq squared over mr squared. How are you going to prove that mq squared? Mq is here and mr squared is equal to 1. We already have that mq. This is such a simple problem. Remember, mq squared, we got mq squared over mr squared is equal to 1. It is equal to 1, so we're not going to write is equal to 1. So what we're going to write is mq squared here over mq squared. Why we replacing mr with mq? Because we know mr is equal to mq from question 10.2. And now both cancels out. The answer is just 1. What is this? Suppose this is a joke because it's just 4 marks. It should not be 4 marks. It should be like 1 mark. This question here. So simple that was. Right, so we already have that. Yeah, we kind of just use this. They shouldn't even ask this type of question. Well, it's trials. That's the reason why you can have errors and, you know, unnecessary questions. Right, let's move on to the next one. Last problem. Question 11. 1, 2. I think we can just take all the questions because, yeah, question 11. I'll just do the working in the side, right? And this ends off our, yeah, video after this. Right, so let's look at question 11. What we have is a very simple diagram. Triangle ABC is right angled. Okay. ED is perpendicular to AB. That's given there. Let's write down all the important information here. AC is 4,8. AC is 4,8 centimeters. Remember? Centimeters. AB is 8. AB, the entire thing is 8. And AD equals BD. Very important information. See, it's not even marked here. AD equals BD. So that's 4 and 4, right? So we're going to put 4 and 4. Calculate BC. Calculate BC correct to 1 decimal digit. BC, we're going to apply Pythagoras here. BC is equal to the square root of what? 8 squared minus 4,8 squared from Pythagoras. Right. And therefore, BC is now equal to square root of 8 squared minus 4.8 squared. They want the answer to 1 decimal digit. 6,4. It worked out exact. 6,4 centimeters. Perfect. So BC, the entire distance BC is 6,4. Nice. Complete BAC. BAC is similar to, let's see, BAC is similar to BAC. It will be similar to BED. BED. Yeah, remember angle E is be equal to angle A. Yes, because that will be the third angle. Remember, we have a 90 degree here. Right, we have a 90 degree here. Right, we have a 90 degree here. Angle B is common. So BAC is this entire triangle. It will be similar to BED. So I'm going to say triangle BED. It's going to be similar to triangle BED. Hence or otherwise calculate the area of triangle ADEC. ADEC. Now to calculate the area of triangle ADEC, we're going to use subtraction of areas. We're going to take the area of the entire big triangle and minus the area of the second triangle. Okay? What's the area of the entire big triangle? Well, we got a problem here because we don't have a perpendicular height. So we need to find ED. So I'm going to use this triangle to find ED. Right? So 11.2. I want ED here, right? So in order to find ED, I'm going to say ED over BD. Do we have BD? Yes. I'm going to say ED over BD. ED over BD equals AC over BC. Do we have AC and BC? Yes. AC over BC. And that's because of similar triangles. Now ED over BD, remember we're calculating ED. So ED is now equal to what's BD? BD is 4 times what's AC? AC is 8 over what's BC? BC was 6,4, and I will get an answer which is 4 times 8 over 6.4. I've got an answer of 5. Perfect. That's 5 centimeters now. So I've got half base times height here, and I have half base times height here. So area of ADEC, so area is equal to half base times height. Area of triangle, the big triangle, minus the area of the second triangle. Half base, what's the base? 4,8. And what's the height of this triangle? 6,4. Right? Subtract half. What's the base of the small triangle? 4. And what's the height of the small triangle? 5. Right, so I've got base height, or you can make base height. Alright, and then what we have here is half 0.5 times 4.8 times 6.4 minus 0.5 times 4 times 5. I'm getting an answer of 5,36. 5,36, not units, because they told us that this is basically, if I take the area of this entire big triangle minus the area of the second triangle, I'm getting, maybe I made a mistake here. I just want to calculate again, put it in order. Half base is AC, the height is 6,4. Let's work it out in steps. Half times 4.8 times 6.4. Right, so I'm getting 15,36. I think I made a mistake here, guys. AC over BC. AC was 4,8. Yeah, that's why that's 4,8 times over 6,4. BC. BC is 6,4. So that should not be 5. ED should be, go back, 4 times 4.8 over 6.4. So I'm getting an answer of 3. This should be 3. Right. So not 5 here, should be 3 there. And that is 6 minus 6. And we should get 15 minus 6 is 9,36 centimeter squared. I hope you guys understood and enjoyed this video. Don't forget to subscribe to my YouTube channel and look out for more content.